Okay, after you have finished the graph, I would like to draw attention to this part. Now here, a must be greater than 1. Okay, actually, that means here there should be a growth. There should be a growth. And then, how about when a equal to? How about when a, which is between 1 and 0, not inclusive? You'll find that these two equations almost the same, except that the value of a for the right hand side should be between 1 and 0. Then we say that there's a kind of curve. Green is not okay. There's a kind of curve of decay, smaller and smaller. Okay, and then there's some characteristic that's important, that these two graphs should be cut the y-axis at 1, 0, and then okay here, and then all the graphs should be above the x-axis. That means the value of y should be greater than 0, important that one. Okay, and then no maximum, no minimum, and then no axis of symmetry. Now I would like to draw the attention here. For the left hand side, the value of a to the power x increase. As x increase, it becomes greater and greater. Okay, greater and greater. But on the right hand side, the value of ax to the power x is decrease and decrease. So it's a decay curve. And then on the left hand side, the value of a to the power x get closer and closer to z when x decrease. That means this part, right? This part. And then on the right hand side, the value of a to the power x is increased, this part. Now, in the coming future, then you'll find that it will give you a good idea to help you to understand the question. The last part is the rate of change. I think if you are studying physics, then for that one, the idea you will be okay to you, quite simple to you. For the left hand side, the graph go deeper and deeper. Okay? So the rate of change, the increase become greater and greater. Maybe I draw the small triangle here. The pen is not quite well. Okay, on the graph of the left hand side, the growth graph, if I draw some steps here with the equal width, okay, then you will find that the height of each step, okay, now that part I highlighted, will become greater and greater. This part will become, then we find that the rate of change, the rate of increase will be increased because that green height become greater and greater. And then on the right, when x increase, the rate of decrease 嗰個減慢嘅速度減慢中。Okay? We jump to the handout, page 17. Okay, let's start. Exponential growth function and exponential decay function. Now, for this part of exercise, please correct the answer to 3 significant figures. And then, now, study. Now, actually, you have come across it in Form 4. Let P of t be the quantity of the subject at a time t if the rate of growth of substance at that time t is proportional to a quantity. Okay, first, now this is a function. That means the quantity p change when t change. T here we stand for time. Okay, and then this part p, we say that it shows the initial value, initial 最初嗰個時刻 okay? We read as naught. Okay, this like 0, we read it as naught, p naught. P naught and then times e to the power k of t. In that part, is a time, t is time, and then k is a coefficient, is important coefficient. And then here, k, in that case, must be a positive value, a positive constant. Now, because it's a growth graph, so the k must be positive, okay? Now, in this graph, it's a growth function. If it's time, x, then I can tell you that this part, conjugate 2, will be nothing here because time, you cannot be negative. Now, I write the function as p equal to p naught times e to the power kt. For that part p, that's okay because here, just emphasize that p change as t change is a way to show it as a function. So both correct. Go to the first example. Talk about virus. Okay, virus. The number of people infected by this kind of virus. And then after 2 days, how many people get infected? Now it's a very horrible, okay, event like the Ebola nowadays. And then the function is here. Initial time, that means when t equal to 0, starting time, nothing happened, okay? Now, when we count it, that means when t equal to 0, therefore, this part now become 1. So p equal to 100. Okay, at the very beginning, 100 people affected. After a week, that means 7 days, the number of people get involved, that means e 0.5 and then 7. Correct to 3 significant figure only. Okay? How many people get infected increased to 700. Okay, so you know that 700. 700 and then initial is, you do not know which time, so it's t. The unknown now is here, index part. So you must take natural logarithm on both sides. And then everyone know that this part become 1. The answer is 3.89. Now if you can't get this answer, make sure that you key in the calculator correctly. Remember, you have to close the bracket. If you use fx 50fh, close the bracket before you're going on, divided by 0.5. Okay? Number 2, your turn to do it. Okay? Make sure that you're talking about the same time after 5 years. Okay? So just take t equal to 5. For this question, that means the initial population is 5,000. Correct to 3 is a figure, that means 22,400 approximately. Okay, find the time when the population grew to 12,000. Now, a point I would like to remind you, that is when you doing some calculation in M1, please try your best, avoid using decimal value, especially if you need to rounding it. Don't do it. Okay, keep all the exact value through the process, through the question. The way, that is, you try to keep the value into a way of a fraction, then you can keep the exact value. Okay, that means after 2.92 years, the population grew to 12,000. As a decay curve, of course, here equal to 1, okay, x-intercept, and then going down and down and down. And then you can just draw the part in project 1. Okay. Let me draw your attention to that value. Okay, we call it nanda. Can you find it? Nanda. We call it nanda. Nanda must be a positive constant when you put it here. we can say that the coefficient of t is negative lambda. Lambda is positive, so this part must be a positive value. So it become the value of q become lesser and lesser, so it's a decay curve. Therefore, when you look at a function, say a equal to 500 and then e to the power 0.2t, and then another is b equal to 500 and then e to the negative 0.2t, then actually you can tell this one, the upper one, is a growth function, and then this one is the bottom one should be a decay exponential function. Just look at the coefficient of t. You can tell. Okay, you see the icon again. Do it now. First, temperature after 3 hours, 110 degrees Celsius. Okay, the answer is 6.93 hours. Okay, do it. Simple. Original value is 100, okay, because that means when time equals 0. And then half, that means 50. Some of you may directly write in this way. That's fine, that's okay. Okay, that means it just takes 17.3 seconds, and then it decays to its half. Okay, try. Okay, I would like to draw your attention to 2 points. The first one is an inequality less than, so we keep the inequality sign, and then it used after n years, so we take it as not t, it should be n. Okay, stop here. What is the sign of this inequality sign? Now, aware that this part is a value less than 0, therefore the sign must be changed. Now, this is one of the common mistake here. Now, let's understand by the graph. Okay, I've drawn the graph here. Now, 1,600 is here. So, to fulfill the question, the value less than